This is also an interesting question, an important question. And this question in this part explains how come a charged object attracts a neutral object. So in this case, the charged object is the charged sphere C and the neutral object is the sphere S. And what exactly happens is when you have a charged sphere C that is brought near to a neutral object, a neutral conductor object in this case, the charges on sphere S will move. So sphere S remains neutral, but the electrons will be attracted towards charged sphere C. So the electrons will move towards the left, leaving lesser electrons on the right. That's the reason why in my drawing I have written that the left side of sphere S, the left side of neutral sphere S, takes on a negative induced charge. The right side of the neutral sphere S takes on a positive induced charge. Together, sphere S still remains neutral, but there's this separation of charges. So the words that we use to describe this is a negative induced charge, a positive induced charge, and together sphere S remains neutral. So once we can accept this, then we can see that the negative induced charge remains over here, this side of the sphere. It takes on a negative induced charge, and negative and positive, they will attract each other, and this is the reason for the attraction. And when we do this, we will see that the neutral sphere S actually will move towards the left, gets attracted towards the left. Now, very interestingly, when sphere S is attracted towards sphere C, sphere S will move towards the left, and when the two spheres touch each other, then sphere S will be immediately repelled away towards the right. And the reason is because of this. Now, upon contact, what happens is the sphere C is very, very positively charged, and therefore it will pull over and attract over the electrons from neutral sphere S. So there's some animation here, take a look at it. Some electrons will move over, be attracted towards sphere C, and this means that sphere C now has some electrons, that it gains some electrons. These electrons is not enough to completely neutralize sphere C. Remember I told you all before that whenever we say something is charged, in this case sphere C is charged in the question, we always assume that it's super duper charged. So despite it receiving some electrons, it will not be able to neutralize sphere C completely. So sphere C still remains positively charged, less positively charged than before, but still positively charged. Alright, for sphere S, you see that it loses electrons over, so therefore sphere S will become it loses electrons, and therefore sphere S will become positively charged too. And that's the reason why upon contact with the movement of electrons towards sphere C, both spheres become positively charged, and that's why we will see a repulsion between the two objects. This is actually a question on forces, on how you label forces, so it's a good time to revise your forces chapter. And these are the three forces: electrostatic force of repulsion, there should be a tension force along the string, and there should be the weight of sphere S.